This is day 18 of Advent of Code 2024 Done and Go, and this challenge is called a RAM Run. You and the historians look at a lot more pixelated than you remember. You're inside a computer at the North Pole. Just as you're about to check out your surroundings, a program runs up to you. This region of memory isn't safe. The user misunderstood what a push-down automation is, and the algorithm is pushing whole bytes down on top of us. Run. The algorithm is fast. It's going to cause a byte to fall into your memory space once every nanoseconds. Fortunately, you're faster. By quickly scanning the algorithm, you create a list of which bytes will fall, your puzzle input, and the order they'll land in your memory space. Your memory space is a two-dimensional grid with coordinates that range from 0 to 70, both horizontally and vertically. However, for the sake of example, suppose you're on a smaller grid with coordinates that range from 0 to 6, and the following list of incoming byte positions of this. Each byte position is given as an x-y coordinate, where x is the distance from left edge of your memory space, and y is the distance from the top edge of your memory space. You and the historians are currently in the top left corner of the memory space at 00, and need to reach the exit in the bottom right corner at 7070 in your memory space, at 77 in your memory space, but at 66 in this example. You will need to simulate the falling bytes to plan out where it will be safe to run. For now, simulate just the first few bytes falling into your memory space. As bytes fall into your memory space, they make that coordinate corrupted. Corrupted memory coordinates cannot be entered by you or the historians, so you will need to plan your route carefully. You also cannot leave the boundaries of the memory space. Your only hope is to reach the exit. In the example above, if you were to draw the memory space after the first 12 bytes have fallen, using dot for safe and hash for corrupted, it would look like this. You can take steps up, down, left or right. After just 12 bytes have corrupted locations in your memory space, the shortest path from the top left corner to the exit would take 22 steps, like that. Simulate the first kilobyte falling onto your memory space. Afterward, what is the minimum number of steps needed to reach the exit? Okay, let's take a look at the input. Okay, that's a lot. When I was reading that, the thought I was having in my head is like, you're running across, and then at a later point, it falls down. So you would have to like plan it out so it's like you can run past one and then it lands down, and the shortest distance from there. But from this, it seems like we're placing everything onto the grid first, and then we find the shortest path. So I'm going to assume that's going to be like part 2, but we can get started. So we've got this lines, each line, and so we want a grid. We want to know which locations are fine to be on. Let's first do grid size so we can do with the testing and do it with the real one. So we'll put that here. Start off grid 7, 0 to 6, and we will want, what do they call it? Corrupted location. So we'll do corrupted is equal to make map, and do we have, yeah, cool, we've got point. I've got point created in multiple of them, and I renamed it. I should have just used the exact same point from before. Actually, I should check, is that XY? Yeah, we got XY in that, which is what we want. And this will return a bool. So we've got the corrupted map, move you to the top there. Now we'll do directions. This is list of points. Now we'll do 0, 1. Okay, we'll start with down. So that's X or Y. So first index Y is the lines in the grid, then that. So down. Actually, we'll start with up. Up, right, down, and left. So we now need to figure out which parts of the map are corrupted. So do for line in range lines. We'll do parts is equal to strings dot split line on comma. We then do x is equal to string conv dot toy. That's parts 0. Then we do the exact same thing for y. And now we do corrupted point x y is equal to true. So that point is corrupted. So we have our starting position, which is point 0. We then have our end, which is grid size -1, grid size -1, and it'll be same thing as we've done before. Just start at a position, check each direction, then add it to the queue, and just trying to find the shortest direction. We also need to save the visited locations so we don't go backwards on ourselves, and so we know which direction is the shortest way. But anyway, we do start with the queue. Let's take a look. What did I do for? I did state. I'm gonna do the same thing except okay, in this one I'm gonna change that to D16, and I will grab state for my one now. But it'll be position point, and we will just do score. So this will be a queue of. No, this one doesn't need to be D16, but this will be state. And this will be starting with state of start 0. And then visited is equal to make map point bool, and then visited start equals true. Now we do for length of queue greater than 0. We do current is equal to queue 0, and then queue is equal to queue from 1 onwards. We then do if current, the condition which is dot position is equal to end. We'll do it up here. Current, we'll initialize it here. So current var of type state then equals queue. And if that's the case, we break output equals current score. So break there, we've got that. But now what we need to do is go through the directions. So for unscore in range directions, and we will next is equal to point. This will be current position dot x plus dot x, and then exact same thing, but now with y. So we've got that. Now we do if next dot x less than 0 or next dot x greater equal to grid size, and then once again same thing again, but with y. If this is the case, we continue because it's out of bounds. Now we do if corrupted next or visited next, continue. And if none of that's true, we set visited next equals true. We then add it to the queue. Now let's see, where do I do it here? Queue. So we do that like this, but it's next and current dot score +1. So we've got that. That should run on this one. And what was the output of that? 22. That gave 12, which it shouldn't have. Okay, let's take a look over it again. So we've got the current one, which would be this. So we're going over it, getting rid of it. If current position end, we break. Directions, point, x, y, current position x plus dir x, current position y plus dir y. In here, let's do, actually, what do we want to do? We will go to here, and we will print this. And maybe I need to print corrupted up here, because it's possible I didn't do this correctly. Whoops, I shouldn't have put that in the for loop. Put that there. Doesn't seem like it went in any place where it shouldn't have. So that does kind of look correct. Okay, how does that compare to this one? So it went to the right, but that one went down. Okay, I need to side by side of that. So we went 0, 0, 0, 1, so 0, 1. Okay, so it did it incorrectly. So I went to 0, 3. Oh, actually, it looks like I've done it in the wrong way. Let's see, where did I do this? So looking at this, we've got like 3, 0 in here when it should have been 0, 3. And then we've got 0, 6, which is when it should have been 6, 0. I'm not sure what's wrong with it. So let's look at the points. So we're doing 0, 0, doing that. Point, doing x and y. X, y. Wait, no, it is correct. I'm just misreading it. So this is... Okay, I see what it's doing. Let's go back. It went 1, 2, 3. Then it did 1, 3, 1, 2, then went up. Wait, okay, so my end is, oh, okay, I understand now. The end I did was wrong. Where are you at, end? Wait, huh? I've got grid size. That is, okay, so it didn't reach the end, it just ended. Was it's not adding everything to the queue, is it? I feel like it's doing this all wrong. Okay, let's start breakpoint there. So the queue has one thing in it. When we go to here, there should be two things in it. There is not. There's only one thing in it. Only one thing is being added to the queue. Why would that be? Okay, well, we'll go to here and try to figure that out. Okay, so what do you have next? Okay, you would fail. That's good. Go to here. What do you have next? You are fine. Apparently not. Apparently 1, 0. Oh, okay. After just 12 bytes have corrupted locations in your memory space. Do I have too many in it or something? So there's 1, 0, but theirs doesn't show 1, 0. Do I need to change that to... Wait, I'm so confused right now. Okay, so then we've got this. Only one thing gets added to the queue. So I might have to do 12. Where are you corrupted? So for total corrupted equals 12. Then we do for i's equal 0, i's less than corrupted, total corrupted I plus plus. Then we do lines I. Is that what we meant to do? 22. Okay, so that is. So now we need to go to real input. 1024. Grid size, that was, what's that for this? 70. So let's run that. 223. Okay, so that's not the correct answer. I must have messed that up. Grid size 71024. Okay, so in that case wasn't able to reach the end. And it seems like it's again... Okay, there we go. Now we've got multiple paths happening there. Simulate the first kilobyte, 1024. That's what I did. Grid size is 70. I'm not sure what's wrong with it at the moment. Oh, I just realized the problem. So it's 0 to 6, and we put 7 in. 0 to 70, we're meant to put 71, not 70. Okay. Well, the only bit of code I changed was putting this into here, because that makes a bit more sense. So it's now putting 0 out, but... okay. 71. Now it should work. 260. There we go. That's part 1 done. Now, on to part 2. The historians aren't as used to moving around in this pixelated universe as you are. You're afraid they're not going to be fast enough to make it to the exit before the path is completely blocked. To determine how fast everyone needs to go, you need to determine the first byte that will cut off the path to the exit. In the above example, after the byte at 11 falls, there's still a path to the exit. However, after adding the very next byte at 61, there is no longer a path to the exit. So, in this example, the coordinates of the first byte that prevents the exit from being reachable are 6, 1. Simulate more of the bytes that are about to corrupt your memory space. What are the coordinates of the first byte that will prevent the exit from being reachable from your starting position? And then provide the answer as two separate integers separated by a comma. Okay, so we do this. Let's see, total corrupted. What we then can do is essentially this same thing again. Let's do this, and we would do starting on this, but then length of lines. So add this in, and then we do all of this stuff. Wait, I'm editing part 1. Okay, let me just copy all of this into part 2. So let's remove that. I'm just going to quickly run it just so I make sure part 1's still working. Okay, that seems to be still working. But we can get rid of the prints that we've done, just so we don't have all that coming up into the console, although you probably will need it to fix any issues I do create. So we do that. We have this. We now need to add it into here. And let's do output -1. And we will do output equals -1 here. We run through all this code. Then we do if output is equal to -1. No, that's not correct. If current.score is this. Was our output Okay, we need to change that. We don't need output anymore like that. Output is now a string. So when we're down here, if this is happening, then output is equal to what is it? Let's see, strings dot f. Oh, is it format? Yep, we do that. %d, comma, %d. Then it would be current. Wait, no, we don't need that. It's just these two, x and y. And I edited part 1 again. Okay, I did all of them part 1 again. No idea how I managed that. Okay, well, I'm going to switch my code for part 1 and part 2 around. Was part 2, my original part 2 still working? Okay, so it didn't print out anything. That might be okay. Need to fix the output here. There we go, part 2. Now it's about figuring out this. And we will switch to this input. We will change it to, let's see, part 2. Grid size 7. And this was 12, I think. Yes, it is. And now we do that. Why is that erroring? Oh, right. Okay, we're just gonna skip running part 1. Okay, so part 2 didn't do anything. So we now need to let's put this here. And then where is corrupted? Let's run it. It's total corrupted. Okay, I guess that just doesn't run or something. I guess we'll have to step through, I guess. Must be my... No. Okay, well, I'm just screwing that up. Well, let's do this. If it doesn't equal end, and what we should be doing is breaking from it. So we are here, going through. Let's actually put it, the breakpoint there. Then where is corrupted? 13. It shouldn't be 5.5. Where is 5.5 in this? Okay, so does it go to here and break? No, it doesn't. Where was this 5.5 on the grid? 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Why would that cause it to not work? I'm not sure. I'm not fully clearing the state. Okay, that makes sense. We will grab all that and put that here. Now it should work. 6.1. And now for the real input, well, I don't forget to change all this. 71.924. And then I uncomment that and we run it. And we got 24.48. And there we go. That is correct. If you like this video, make sure to like and subscribe.